Hello Year 5, welcome back to virtual maths lesson number 2. Now today I thought we might cast our minds back to the start of this term when we were looking at factors and common factors. Factors we all know, numbers we can multiply together to get to another number. For example, a factor of 10 is 2 and 5 because when we do 5 times 2 it makes 10. Now common factors are factors that are the factors of more than one number. So for example, 6 and 9 both have the common factors of 1 and 3. And top tip for you, 1 is the most common factor of all because it's a common factor of every single number out there, every single whole number that is. Okay, let's have a look then. We're going to go through different methods to find out the factors of numbers, and then I've got some questions for you to have a go at later on as well. Just like yesterday, you're going to need a paper and a pencil. Let's get going. Okay, number 1, we can use arrays to help us find factors. So an array, nice and simply, is organising counters or objects into a shape that is regular. Just like yesterday, we were looking at our regular rectangles to help us with our compound shapes. So how many ways can we arrange an array? 8. I'm going to start by doing my 8 counters in one line. So that's 4, 5, 6. Oh, hang on a minute. 6, 7, 8. Double check. I've got 4 and 4. That's 8 counters. So I know that my factors of 8 must be 1 and 8. 1 and 8 must be factors of 8. So I can arrange them in one long line. Lovely. Let's go back. Let's do another array. This time I'm going to do lines of 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Now I can see I've got 2 lines and I've got 4 on each line. So I know that my factors of 8 also have to include 2 and 4. Lovely. Okay, I'm going to try one more array. Let's see if I can make it work. 1, 2, 3, 4, 5, 6, 7, 8. So now this is not an array because I've got a missing gap, so I cannot use this as an array because it's not made a regular shape. I would need one more there. So that tells me that I know my factors of 8 are 1, 2, 4 and 8. I also know because I've got 4 and that's over half, I don't need to keep counting my arrays. So that's one way we can use arrays to help us find factors. Okay. We can also use our friends the factor bugs to help us out. Now remember, every single number has at least 2 factors, 1 and itself. So in this case, I've got the factor bug of 12. I've got 1 and 12, and those are going to make up our little antennae. And every single number is going to have these 1 and itself at the top of our factor bug. Then I've gone round and I've added the legs. So I've got 2 and 6 and 3 and 4. Now I know that I don't need to repeat my numbers, so I haven't gone on to add another one of 4 and then 3 again, because then my bug has too many legs and it gets a little bit confusing. So I've stopped when I've got to 3 and 4 because I know my next one would be 4 and 3. Okay, big one. We can use our multiplication knowledge to find our factors. I know you guys are all fantastic at your times tables, so this bit is going to be really helpful when checking if numbers are factors or not. For example, I know that 5 is a factor of 35 because 35 is in the 5 times tables. Because it's in the 5 times tables, 5 must be a factor of it. I can do another one. I could say, I know that 7 is a factor of 28 because 28 is in the 7 times tables. Have a go yourself. You can pause me for a minute, have a go at finding different factors. Which ones can you find using your multiplication knowledge or the multiplication grid to help you out? Okay, in this method here, we can also use a grid, a factor grid to help us. Now I've filled out this already. I've got my 6 factor grid here. I know that the factors of 6 are 1, 6, 2 and 3. Now I've carried on filling in my factor grid. I've done it by going down 1, 2, 3, 4. I've just gone all the way up to 4 to show you what happens when we reach a number that is not a factor. Now I cannot divide 6 by 4 and get a whole number, so I know that it's not a factor, and I've put a cross there to remind me. I've also got this snazzy dotted line here just to prove to myself that, oh look, I've got my 3 times 2, but I've already got that up here, so I don't need to repeat it when I'm counting out my factors. Let's have a go at number 24 together. Let's have a look. Feel free to join in as I go through this. Right, 1 times what makes 24? Nice and easy. Every single number has a factor of 1 in itself, so that's going to be 24. Lovely. So now I can divide 24 by 2. Let's see if it gives me a whole number. It should do because it's an even number. 24 divided by 2 is 12. So I know that 2 and 12 are factors. Then I can go on to do 24 divided by 3. Or 3 times what makes 24? Well, I know that one. That's going to be a nice 8 there. So I know that 3 and 8 are factors also. And then I can look at number 4. Well, let's have a look. 4 and 6 are factors. Now I'm looking at the next number and I'm thinking I might have to put a cross here because I know in my 5 times tables it has to end in a 5 or a 0. Let's have a look. Yep, 5 is not a factor of 24. Lovely, and I'm going to do that last one. 6 times 4. Oh, we've got a repeat, so I can stop there. And I know that the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So I've got lots of factors there. Now this question at the bottom says the common factors of 6 and 24 are. Now to find that out, I've got my factors of 6 and I've got my factors of 24. So I know I can look at that and go, right, well 1 is on both of them, obviously. I know that 2 is on both of them, which I could have guessed because actually they're both even numbers. I know that 3 is on both of them because 3 times 2 makes 6 and 3 times 8 makes 24. And I know that 6 is on both of them because 6 times 1 makes 6 and 6 times 4 makes 24. So my common factors of 6 and 24 are 1, 2, 3 and 6. And that is how we use the grid to help us keep track of our factors using our multiplication knowledge. So that is several methods to help you find factors. I'm going to take you through the activities for you to do today. Obviously, you can pause me and leave me up on the screen so you can have a look at the questions as you are answering them. And you can always go back over this presentation to have a look at another section if you need any reminders. Okay, so the first section is all about using arrays. We've got 24 arranged in different arrays. And I've got a little think point for you. What other area of our maths learning does this method of finding factors remind you of? Maybe have a look at the shapes in play here. Once you've found out the factors of 24, have a go at arranging 12 objects. You can do this as dots on your paper, or you can find actual objects to arrange as well. So you can have a look at the different arrays. Again, can you make arrays of objects you find around your home? Remember, arrays must be arranged into a rectangle. It's got to be a regular shape if it's going to help you find your factors. Then moving on to our factor bugs. I've got the factor bug of 18 here for you and the factor bug of 36. Now the top hint here is one of these bugs is going to need a tail. If you remember back to our learning in school, the tail means that you times it by itself. For example, if I had the factor bug of 9, it would have the little tail of 3 on it because I know 3 times 3 equals 9. I don't need to put 3 on there twice. I just turn it into a little tail at the bottom of my factor bug. Now remember, we do not repeat our numbers, so make sure you don't give your fact bug too many legs, otherwise it might feel a bit clumsy. And then a little think question for you. What do you notice about the factors of 18 and 36? And then I've got a little thing for you here to find the common factors of 16 and 28 using the factor grid. Remember, if you've got a number that does not have a factor pair to it, then you need to put in a cross on the grid next to that number. The next activity is all about the Venn diagram. Can you find the factors of 20, the factors of 30, the factors of 36? But, top tip, if you've got some that are factors of 2 or more of the numbers, you need to put it in the middle section of the Venn diagram and then answer these questions at the bottom here. And then you can choose your own numbers to explore common factors with which numbers have the largest amount of common factors that you can find. A little challenge for you there. And the very last one is a brilliant maths challenge for you guys. Take in the numbers 1 to 16. Can you fill up this grid using the numbers only once? There is an answer to this one where every single number is used once. Can you find it? Now, a bit of a top tip for you. A prime number has only 2 factors, one in itself, so it's only going to have those antennae. Have a brilliant day doing some maths, guys. Remember to check the website for Mrs. Boy's fabulous festive maths challenge day 2 as well. Thank you very much, guys, and I'll see you tomorrow.